In this video, I'm going to show you how to take a boolean expression and translate that into a digital circuit. So the way that we do this first is by understanding the order of operations. So as you remember from class, the first thing we look for are parentheses. In this case, the parentheses indicate that this P and Q is ORed with R. So our entire statement here, we can consider as, we can put up a variable as S as our entire statement. That's our output. So I'm going to put over on the far right here that we have S as our output. We can observe here that we have P, Q, and R as our inputs. So we can just go ahead and put P, Q, and R on the left-hand side as our inputs. Now then it's just a matter of figuring out how these go together. So as I indicated before, these parentheses tell us that the first operation that we do that leads to the S is an OR operation, which actually means that's the last operation we do. So to lead to the S, we know we have an OR. So OR is shown like this, and we've got two components going into the OR. Now it doesn't hurt to write on here, so let's go ahead and write the two things we have coming in are not R and P and Q. So let's take the simple one first, the not R. To get a not R, all we have to do is we have to take R and we take the not of it. So we put a not there and we get not R. Piece of cake. Now to get P and Q, that's also quite easy. We just have to and the P and Q. So here's our gigantic and symbol. We and P and Q. And now we have a representation of the digital circuit that corresponds to our starting Boolean expression.